As far as I remember, I've never owned a digital wristwatch, even the ones shown here from Texas Instruments from the 1970s. And I definitely do not have any type of smartwatch today. I always thought the Dick Tracy smartwatch was an interesting idea, and now we're really close to it today. Mr. Toastmaster and fellow Toastmasters, today I want to talk to you about 3 long-lasting watches, 2 that I'm working on, 1 that I've researched. And I want to talk about what I've learned about them and some ideas about what I've researched during that. First one is a watch that I received from my father after he died, and it's a mechanical watch. And I really liked this chart here to show what's going on within a mechanical watch. It's been declared to be pretty much standard technology, no innovations with it, but I really like this diagram to show what's going on within a mechanical watch. So on the far right side, you see the mainspring, which is the key part of this. And as the mainspring is wound up and then begins to unwind, it then triggers the barrel to start moving. And it's the barrel that starts getting all the other gears in place to start keeping time. And you can see there's gears tied to the second hand, to the minute hand, to the hour hand. Intricate piece of device here, very intricate what's going on here. And one of the things that's really interesting is that the ticking that you hear within a mechanical watch is caused on the left side by the balance wheel. And there's actually interesting videos that have been done today unwinding the entire watch instead of making it a linear setup instead of compacting it into a very tight area. And it's interesting watching how all that comes into play, how all the gears come into each other and cause the timing. And one thing I learned too, and I've always heard the word jewels talking about wristwatches. I never really understood what jewels meant. And literally jewels are meant to put on to the top of the gears, as you can see in this diagram. And they were used to reduce friction. So apparently a jewel against steel has less friction than steel against steel. So it's meant to provide longer life. And today, high-end wristwatches will often have expensive jewels because they become a status symbol. But typically you can get by with sapphire or rubies, or doesn't have to be diamonds, doesn't have to be a really expensive type of jewel. It's meant to reduce friction, which I thought was a really interesting idea. Another reason that I really liked this chart is that it's hand-drawn. Today with all our CAD tools, we would have put that into a CAD program and use that to show what's going on. But this is hand-drawn, and I thought this is a lot of detail to put into this blowout cutaway diagram of what's within a pocket watch. And a wristwatch is similar, different layout in that usually the windup is on the side, not on the top. This is the watch that I have from my father. It's currently out for repairs for a second time. Gruen was an American watch manufacturer from about the turn of the 1900s into the 1950s. This watch is from the early 1950s. And one thing that's really interesting about this watch is that it advances every half second. Not every second, but this watch advances every half second. So probably a different design point, different gearing, different ideas as to how to do that. And you can see that on the side is an ad from 1917 where Gruen was advertising watches. And so they were from Cincinnati, pretty much a key US watch manufacturer until after World War II. And one thing I learned during my research is that wristwatches for men became a fashion statement after World War I. Until World War I, apparently pocket watches were the thing to have, and wristwatches were deemed to be not masculine enough. The soldiers in World War I, though, were required to wear wristwatches, probably to keep a hand free. So when the soldiers came back from World War I, wristwatches for men became a thing. So again, this is a photograph of the one that I have out for repairs right now. So the second watch I want to talk to you about is the next step in technology for wristwatches, which is going to quartz. A lot going on in the chart. One of the reasons that quartz was used starting in the late 60s into today is that quartz can get, as a tuning fork, can generate an extremely precise frequency. And with the right electronics used to tie to that frequency, it can kick off a trigger every second, and it's much more accurate than the mechanical watch. So as the quartz vibrates, the electronics are in sync to that frequency, and then every second it sends a signal to the motor, which then starts all the other gears in place to get second hand, minute hand, hour hand moving. So we've now moved from wind up to batteries, and now there's some concern that maybe we've got too much pollution now with all these watch batteries being recycled or thrown away. But from convenience and from accuracy, quartz has been the way to go. And in fact, quartz led to a huge crisis in the 1980s, going from the Swiss and European domination of the watch market now into a new set of manufacturers coming out of Japan. Too far. Can you restart it, please, Craig? I went one step too far here. Thank you. So what's on the left is the first quartz wristwatch, Seiko, 1969. And it's typically what we've seen in other technological changes, in that a company comes in and totally flips the market over. And that's what happened here with quartz watches. The European manufacturers were slow to come on board. Now we have a whole new set of Japanese manufacturers doing watches. And this watch on the left is also from my father. So this is probably from the 1980s or 1990s. And I have him wearing it today. So I have two of these wristwatches, a mechanical and a quartz, have some lifetime behind it. And now there's a third group that's looking to build a much longer timekeeping device. In fact, they're looking for 10,000 years. And this is a project that is going on right now. Danny Hillis, who had a parallel computing company in the 1980s called Thinking Machines, has now moved and is now working on building a device that can keep time for 10,000 years and use materials that can be easily replaced. So no electronics, no high-tech materials, all materials that can be used to keep time. And they have now two mock-ups and are building a full-size version in Texas today. And I really like this on the far right, in that they're now looking at 5-digit years. So they don't want to have a Y10K issue. So they are literally building, there are mock-ups of this, and now they're building one in the mountains of Texas, and there's a second one that will be built in Nevada. Both of these have been funded by Jeff Bezos from Amazon, along with Danny Hillis, along with the Design Point. Mock-ups are in a couple of museums around the world right now. So they are planning to keep this time without any electronics. In fact, that's why it says there's a digital mechanical computer there to help manage time. So it's not using silicon or any kind of high-tech material for that. So again, the first one is being built in a mountain in Texas. You can see the details as to what's going, how big and how deep the hole is going to be. Part of it is that they want light to come in every day to help reset the clock. And the materials that they're using, which are also shown on the screen, are meant to be easily available to any people from today to Y10K to be able to fix it. And their view is that we've got pottery materials that are 4,000 years old that we found, pottery fragments. Why can't we, as a technologically advanced civilization, build a device that can keep time for 10,000 years? Interesting thought. You can get some idea of the scale of the gearing here. So what's on the left is the mock-up today, and what's on the right is actually the gearing that's going into the clock in Texas. So you can see this is a big timekeeping device. In fact, they also talked about not wanting to have valuable materials in this to prevent people from coming and stealing material from the clock. So it's meant to be relatively common materials, can be fixed depending on what level of technology people have. So I thought about, why am I holding on to these two watches? I mean, I've obviously put in enough money on my first repair of my dad's mechanical watch. I've got a second repair coming. By this point, I could be long on the way to a really strong digital watch. And then I found a quote this morning from Karim Rashid, who is an industrial designer. He wrote, "What really endures are artifacts, effigies, things that speak about a time, place, or civilization. When people say to me that everything seems meaningless, I believe the opposite. Objects outlive us, and they are the symbols of our culture and history. So I believe the team building the clock in Texas believes that. And part of it for me is that maybe it's a connection to my father, who's been gone 20 years now. Maybe it's something that I can pass down to my grandchildren. Maybe it's a way to show that something can continue to exist. So I ask all of you to think about what's in your life that you want to preserve and to be able to keep forward and maybe keep within your family as memories. Back to you, Mr. Toastmaster.